Hello. Hello.
Good evening, sir.
Good evening. Did you see my screen?
Yes, sir.
Okay. Hello and good afternoon, everyone. So today's we are starting the second week of that online session. So the course name was Symmetry, Stereochemistry, and Application Course. All are able to see my screen? Hello.
Yes, sir. Yes, sir.
Thank you. So the course instructor was Professor Anshuman Roy Chaudhary, and I am Probir, teaching assistant of this course. So, like earlier classes, I have talked about that UPAC nomenclature of the organic compounds. So today we are going to solve some problem regarding this. So before solving some problem, so just a brief introduction of this. So what is UPAC nomenclature? So UPAC name is the generalized name of that organic molecules that are applied for the all over the world, and it's the common name that anyone can identify the molecules. So like that, to get a UPAC nomenclature, we have to remember three things. One is the prefix and what is the parent molecules, and another is the suffix, which are mainly the functional group of the molecule. So if you consider this molecule, so there will be suffix will be this alcohol group and prefix will be this methyl group. So if you and we have to find out the parent molecule and parent
Sir, the
molecule.
screen is not visible actually.
Okay,
Sir, now visible.
1 minute. Now it's
Sir, 2 seconds earlier it was visible, now it has gone.
okay. Now,
Yes, sir, visible.
so just I'm starting that you have to give the generalized name of this organic compound, just that everyone can understand of this about the molecule. So to get that UPAC nomenclature of these molecules, we have to remember three things. One is the prefix and identify the parent molecule, and the suffix. Suffix is generally that functional group are present in the molecule, and prefix will be what are the substituent present in that molecule. Like in this molecule, the substituent is methyl, and then we have to um, number that parent molecules about that what the functional group will be the highest priority, like this. The number will be like this example. So this the if we start the numbering from this side, so from this side will be numbering will be start, and so there will be total 4 carbon, that is the will be the 3 methyl butanol. Like this we have to um, give the UPAC nomenclature. So there 1 minute. So that what is the rule of this UPAC nomenclature? So I have writing here. So the in UPAC nomenclature, so we have to find out the longest carbon chain. So after, so first we have to find out the which chain is the longest one. Then we have to numbering this carbon atoms, and the number of the carbon atoms in the present chain sequentially start numbering from the end that gives the substituent the lowest possible number. If there are multiple substituent assigned number to them, then based on their positions on the carbon chain, we have to number them. Then substituent of prefix, that what are the substituent are present in that main chain. Then there will be suffix, like which functional group are present into that main chain. Like if it will be alkane, then that will be end with alkene, end with the ene. If there will be alkyne, then end will be yne. If alcohol, we have to place ol. Like ketone, we have to place one. Acid, oic acid, like that. Then numbering for the functional group. Then if there will be multiple substituents, so alphabetically we have to number also them. Then what then that the substituent prefix all are connecting through that through a hyphen. Then we have to use the locant number of prefix is present, like two prefix is present, like we have to use that di, tri, etc. And if there will be some double bond, and if there will be some cis or trans confirmation, then we have to use for trans confirmation we have to use the e, and for cis confirmation, that is Jusamen with the Germany. What it means that together we have to, for the cis confirmation, we have to use the jet. Now this is the first example. So we have to give the UPAC name of this molecule. So like this is an amine molecule. So for this amine molecule, that we have to find out that in the amine, like this, the if the amine is like this NH3, so in presence of hydrogen, there will be three other substituents are present. So we have to find out the substituent, and the number will be start from this side. Like this will be 1 and this will be 2. So here this will be 1, this will be 2, number 2 carbon, like that. So here this will be 1. Like that way we have to number them. So this will be 2, this will be 3, this will be 4. So what should name of this molecule if the name it is? Someone suggest? Hello?
Sir, N-ethyl, N-methoxymethyl, 4-methoxybutane.
N-ethyl,
N-methoxymethyl,
okay, N-ethyl, N-methoxymethyl,
4-methoxybutane.
butane, then
Butanamine, sorry. 4-methoxybutanamine.
so the name will be, you can place like N-ethyl, you have to write there, or you can write like, if someone started like ethyl, like the past substituent, so here will be, we have to choose like that, that the shortest number of chains which are present, then that will consider first, then the longest, like that we have to. So the shortest will be like this ethyl, and between this there will be 2 and there will be 3. So we are starting with the ethyl one. So in ethyl, then in this will be number 1 position, so you can write like 1 methoxymethyl, or you can write methoxymethyl, whatever. And this will be 4 methoxy butanamine. Then the next one, so there will be, one is triple bond here, another is double bond present in this molecule.
Sir, can you uh, go to the previous slide?
Okay,
Okay, sir. Thank you, sir.
so first that amine molecule, we have to find out that what substituent are present, and in between substituent maybe they will be that number of chain wise, or maybe they will be alphabetical word wise. Generally the chain wise will be better, so you have to go that which chain is the shorter chain, then we have to go the longer chain. You can place this ethylamine as last, or you can place the ethyl will be first, like all are, it's okay. So between these two functional groups, so there will be triple bond and then double bond. So which functional group come first? Between double bond and triple bond, if they are in the same position, then double bond will be the highest priority. Like double bond will be start with the number 1 position. Like starting, the numbering will be starting from the double bond. And if there will be the functional group there, the functional group starting from the triple bond, so the numbering will be started from this side. So 1, 2, 3, 4, this one will be 5, 6, 7, this one 8,
Sir, can you
4,
explain the
5,
numbering
6.
again?
So if there will be double bond and triple bond in the same position, like there will be this side is will be nothing is present. So if we start the numbering, so this will be number one carbon and this will be number one carbon. For these cases, then we just start the numbering from the double bond side. Okay. And if there will be double bond and triple bond present, but the triple bond will be that in that last end of the chain. So then we start the numbering from the end chain, not where the double bond is present. Like from this side we cannot start the numbering. Like from this side if we go the numbering, then double bond will be 1 2 3, number 3 position. And if from this side starting, then triple bond will be number one position, so that will be prefer. But if this chain are not present, then the numbering from this side will be double bond will be this side, then starting the numbering from this side only, and triple bond will be the last number. If there, if 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 anyone is that in the last chain, like the end chain like here, so there is that after double bond there will be another carbon atom are present. So for these cases, we just start the numbering from that where the functional group will be started. Understand? Hello. Hello.
Yes, sir.
So if we start the numbering from this side, so 1 2 3 4 5 6 7, this 8 9 10 11. So what the name of this compound? So what will be the prefix? So this one will be our prefix. Hello.
Yes, sir.
Yes, sir.
Okay. So this will be 5 methyl. Then total number of carbon atom is how much? 1 2
11.
11.
11. So for 11 there will be on deck.
Undec.
Okay. And then on deck 7, that number 7 position there will be n. So 5 methyl on deck 7 n and 1 ine. Or you can write like 5 methyl 7 n on deck 1 ine, like that. Okay. Then we have to find out that if there will be like, if your question will be the MCQ type question, or if not, there will be, you have to, if there will be double bond, then you have to go that it will be E or Z configuration. So if here it is E or Z configuration, cis or trans, because there are two hydrogen is this side, same side, so it will be cis conformation. So for cis conformation it will be Z. So you can name it like Z 5 methyl undec 7 and 1 ine. Okay. For next one, so from which side we start the numbering? From triple one side.
Yes, sir.
So from this side we start the numbering 1 2 3. So this will be 4, this will be 5, this will be 6 7. So from this side it will go the 8 9 10 11, and from this side it will go 8 9 10 11. So all that are same, so you can go this side or this side, all are at same. Here also the triple bond as from the last end, so you just start the numbering from this side, not from this side where the double bond in the second position. If double bond, if this carbon chain are not present, Then we just start the numbering from this side. So what should we name? Someone can tell.
Sir, 6 methynyl, 4 methyl, 8 propynyl, undec, uh, 9 in 1 ine.
So you tell 6 methylene, this one, then 4 methyl, total number of carbon is 11. So at 8 position there will be another group. So this group is
Propynyl.
propynyl. So if we start that alphabetical word, so there will be, so this 4 methyl you can place first or ethene this at 6 position, that methylene group. Oh, so this group what you tell at 6
Methylene.
methylene. So this name will be 4 methyl 6 methylene and 8 propynyl. Total number of carbon atom is 11, that undec 9n19.
1 9.
So this will be, then we have to find that this one is the jet conformation, like this CH2 are in the same position. So 4 methyl 6 methylene 8 propynyl undec 9n19. So you can also give the numbering also this side also, that at what position. So from this is the main chain, so number one position will be this. So if this side will be, there will be double bond, like here it's double bond present, so there will be number one, number two position, then the double bonds, and then you have to tell that two propynyl group or three propynyl group where the double bond is present from the main chain at where the double bond, next double bond is present. Then we have to give the nomenclature of the bicyclo compound. So you know about the bicyclo compound. So bicyclo each compound is will be like this. So there will be fused ring. That is that there will be a common ring present in between this. So these are a bicyclo compound. There will be common position like this position. So to name that bicyclo compound, so we have to naming like that. This is the bicyclo, and then we have to tell that which carbon atoms, which number of carbon atom are connecting. Like we have to start from the big carbon, that big cycle one. So there will be one, two carbon atom presents, and in this one there will be one carbon atom. So we have to name like that bicyclo 2, then this will be 1, then number of carbon atom, there will be no cycle in between this, that will be the 0, that is the bicyclo 210, and there will be total number of carbon atom 1 2 3 4 5, that is the pentane. Like this we have to number for the bicyclo compound. So for bicyclo there will be some rule is given here. The parent structure is the larger the two fused ring. Count the number of carbon atom in the present in the structure, determine its size, then number of atoms present in the both the ring. Then we have the numbering will, name will be like that bicyclo in third bracket. That is that if there will be four carbon atom present in that one ring, there will be 4 3 0. So total number of carbon atoms are 4 3, and there will be 2, that is the non-n. Like that we have to number. And if there will be any substituent present in that uh, uh, bicyclo compound, like here any substituent present, so the number is starting from that connecting point, then we have to go to that substituent, the where the substituent is come. So if if there will be substitution like this position, then the number will be starting from this, and this will go number 2 position like that. So from here, so we have to IUPAC nomenclature of this compound. So there will be two ring present, like one ring is like this one, and another ring is like this one, and this one is the common, like this double bond O and CH2. These are the common between these two rings. So we have to give name of this compound. So how we can start? So we have to find out the prefix one, and we have to start the numbering where that prefix will become first. So we can start the numbering. So from which side we can start, and the numbering will be start from any connecting side, the any common side. We have to start the numbering. So there will be two possible. That is, starting the numbering from this one, or this one also one. So if you start like I have given that from the lower side. So this will be one, this will be, so then we have to go that larger ring. So in between this, the right hand side ring is the larger. So you have to go the larger ring first. Then one, two, three, this will be four, this position will be five, this carbonyl will be six, this will be seven, and this will be eight, this will be nine. And another numbering will be start from like this carbon atom. So this will be one, this will be two, this will be three, and we have to give that numbering from that larger ring side. We cannot go that lower ring. So you can start from this one, and this carbonyl as two. So that keto will be the main functional group which coming as two. That's not right. So you have to start the numbering, and we have to go that larger ring side. So there's one, two, three. So this will be four, this will be five, this will be six, this will be seven, and this 8 9 you can place. There will be another possibility, so you can start from 1 2 3 4 5, and this will be your 6, and this will be 7. Then you go this side, this will be 8, and this will be 9. So in between these, which are most accurate? So you have to go that the larger ring size. So for if you go the larger ring size, all of these are correct. Then we have to find out that what the substituent are present. Like if I go this side, so at number 2 position there will be substituent like methyl, and if you go this from this side, so that number 2 position there will be fluoro. So these two all are okay, you can go any side. But if you go from these sides, then that number 7 position there will be ketone group, and if you go from this side, that number 6 position there will be ketone group. So you have to remember that the main functional group should be that lowest position, lowest number. And if you go that n side, so this will be 6 position, there will be 6 7 8 9. So this ketone will be even further. So you have to don't go that side where there will be main functional group which even further, like number is even further. So we have to choose that side where that your main functional group will be that lowest number. So like this, then what will be the name of this compound? Someone getting my point or not?
Sir, 4-fluoro, 2-methyl, bicyclo, 322, known 18 6 on.
4 fluoro 2 methyl Bicycle
Bicycle
3,
322
1, 2, 3, 3, 2, 2,
known 18
known 8, 10, 6,
uh,
1.
61. Yes.
Okay. Yes, that's the correct. Then that we have to numbering of this molecule. So this molecule, if there will be double bond and present, like
Sir, can you share the previous slide, please?
I,
Okay, sir. Okay, sir. Okay.
so this as a Indian molecule, and from this Indian or naphthalene like this molecule, like bicyclo, what we are telling that our connecting point will be that starting number. But if there will be any naming compounds are already like naphthalene, this like Indian molecule like that, then the numbering will be start from that the main functional group, and the number will be starting from that small ring one. So in between this ring is the six member and this ring is a five member. So the numbering will be start from that small ring. And for bicyclo we just start the numbering from the connecting point, but here we start the numbering where the functional group are present. Like from this one will be our starting number. So then what's the name? So the starting number will be this side. So we can go 1, 2, 3. Then this the connecting side will become last. So from this side if you go, so this will be 4 and this will be 5. From another side you can go 1, 2, 3. This can 4, this can 5. This is 6. But we have to remember that our functional group should be the less number. So this will be most favorable side. So this will be Indian, but there will be no double bond present like hexahydroindane, and where the carbonyl group are present like 1 position and 5 position. So hexahydro 1,5 dione, you can name this compound. Hexahydroindane 1,5 dione. Then the next cyclic compound is that spiro compound. Spiro compound means where that junction is in the one carbon. So in this spiro compound, then we have to go that lower number of ring first, like this. If the spiro compound will be like this, so there will be number of carbon atom 1, 2, 3, 4, and there will be number of carbon atom 1, 2, 3, 4, 5. So we have to go from lowest to higher side. So this will be the opposite from that bicyclo compound. So from bicyclo you have to going from the highest to lowest side. So here also you have to going from lowest to highest side. And here the starting point will be not the connecting point. The starting point will be that position where there will be functional group are present, main functional group present nearer. So we can start from this side like 1, 2, 3 like that, or you can start from this side 1 and this 2. So if placed like this 2, so this side the main functional group is at place at number 2 position, so that will be more perfect. Then the rest will be same, the 1, 2, this will be 3, this will be 4, this will be 5, 6, 7, 8, 9. like that you can number it. So if a number will be like this, then what will be name of this compound? Someone tell.
7 chloro, 9 methyl, spiro, 4 5 dec, 2 on.
So name will be like this: 7 chloro, 9 methyl, spiro, 4 5 dec, 2 1. Then for this molecule, someone can write. So this like, so from which side we can start the numbering? So this is the simple molecule. Anyone can tell who are not responding.
Sir, carboxylic acid side.
Okay. So from this side we can start the numbering. So what should be name of this compound? Someone those who are not respond anything they can tell. Like Sumit. Okay. Someone tell what the name of this compound.
So 3,6-diamine hept 2,4-diol 1 oic acid.
Two. This is the acid, na? So if you consider this as a acid, so you have to not consider this as a ketone group.
Sir, 3,6 diamino, 4 hydroxy, 2 oxo, heptanoic acid.
So like this ketone group, we can tell like not as a main functional group. We are not taking as a ketone as a main functional group. Then we can use this ketone as a oxo. So our main functional group will be like this acid. So the name will be 3,6-diamino 4-hydroxy 2-oxo heptanoic acid. Then for this compound, this what type of compound it is?
Butyl
Ester, sir.
chlorine.
Yeah. So what the name? So this will be the ester compound. So this functional group is the ester. So what should be the name? So the numbering will be from this side. Then tell what Sumit. Hello. So these are the tert-butyl group, and so we can start the numbering from this side: 1, 2, 3, 4, 5, and this will be 6. So what the name? Anyone tell?
Tart butyl, 4 amino, 3 fluoro hexanoate.
Yes. So this tert-butyl, like you can place at last or you can place at first also. Okay, you can tell like that 4 amino 3 fluoro tert-butyl hexanoate. you can tell like that, or you can place that tert-butyl first and the rest of that like same. Then we are coming to the point group. So in between this UPAC nomenclature, any doubts are remain?
No, sir, but they are little bit confusing. Confusing.
Which one is confusing?
So the ester ones.
So ester one. So from this group are, you know that these are the ester group.
Yes, sir.
Okay. So from the ester group, so the main functional group is the ester. So you can start numbering from which carbon. So these are the substituent for the ester. Like ester group will be like R C double O R. So after C double O R. So after O R, so these are the substituent. Like if there will be methyl, then we got like that methyl one. This will be tert butyl or anything like that. So this will be not the part of the main chain. So the main part of the chain will be starting where the ester is connected. So the ester is connected in the main chain will be this position. So that one you understand?
Okay, sir. Okay.
Uh, so we cannot start the numbering from this side. So this will be the for the ester, that what that substituent present in the ester. So that main chain the ester is linkage. So for acid what we are doing, the where the main acid is linkage, we not going to this side. So in place of hydrogen there will be tert butyl group present in for the case of ester. In place of hydrogen there will be one alkyl group or allyl group, another group is present. So but our main functional group is connected in the main chain will be like this acid. So from where we start the numbering. Okay.
Yes, sir. Yes.
So now mm, we are go to that point group and we are solving some problem regarding that point group. So what the point group describes, so a point group describes all the symmetry operation that can be performed on a molecule and that result in a conformations indistinguishable from the original. So point group is the operation. So after that operation that our main molecules cannot not change. So they're indistinguishable from that original, and the point groups are used in the group theory. This is the mathematical analysis of groups determine the properties such as molecules and molecular orbital, etc. So we have to identify the what the point group, like a simple molecule. If you consider like this one as a water molecule, so this will be our oxygen and this will be our two hydrogen molecule are placed. So what operation we can do in this molecule that after that this molecule will be remain same. So if you rotate this molecule 360-degree, like if you rotate any one 360-degree, then what will happen? So it will be same. If you rotate this one 360-degree, it will be always same irrespective of any molecule. But if you rotate this molecule like 60-degree, so after 60 degrees, like 360-degree means you can tell is like a circle. So if you rotate 360 degrees, so it will be complete circle. So if you rotate this molecule like 180-degree, then what will happen? So if you rotate this molecule like 180 degree, then this hydrogen will be coming here, and this hydrogen goes there. So it will be remain same. So at rotation of 360 degree it will be remain same. At 180 degree rotation also it will remain same. But 180 degree rotation only from this side, if it is possible to rotate the molecule 180 degree, then it will be remain same. But if you rotate this molecule like 180 degree from this, so this hydrogen will be not at similar position, like this are coming this side, so this will be come from far side. So only this side are possible to rotate this molecule like 180 degree. So like that, after that rotation, if this molecule are giving same, so like if they are that one after 180 degree rotation, if they are giving that same molecule, so this the rotation will be 360 divided by 180, that is the C2 rotation. Like that you can tell. Like here also the possible various possible of C2 axis present in this molecule are giving here. Then another one is that sigma plane. What is the sigma plane? So if you cut this molecule like from this side, and if you place the mirror between these two molecules, so this will be exactly same to each other. So and if your sigma plane will be is placed in this molecule, this will be our principal axis, and if your sigma is placed along the principal axis and contain the principal axis, what you can tell, then this will be sigma b operation. And if they are like this side, so if this molecule can cut like this side, so for this molecule this is not possible. If we cut this molecule this side, so the two hydrogen is below, there will be nothing in above, so we are not uh, that will be no presence of this plane, so there will be no sigma h plane, that is that which is the perpendicular to the principal axis, that are not present in this molecule. So sigma is present in this molecule, like if you're cutting, like your principal axis will be like this, and you cut your molecule like horizontally. Then there will be another operation like a improper rotation. So what will be improper rotation? So after rotation, then if you give the reflection, and after reflection if you give the original molecule, then that will be your improper rotation, and that we are called as S rotation. Here will be the rotation of 90 degrees, so it will be given like S4. Like this brief introduction, then we are going to solve some point group of this molecule. Like for this molecule, so for this molecule, what will happen if you rotate this molecule at what rotation this molecule will be looking like same? Someone can tell.
360.
120.
So 360 degree, every molecule can rotate that 360 degree, and after 360 degree rotation it will be same irrespective of any molecule, and this 360 degree rotation is, we can name it like E operation. So if you rotate this molecule one, someone tell like 120 degree like this. So if you rotate this molecule 120 degree, then what will happen? This fluorine which coming here, and this hydrogen will be go there, and this chlorine is coming here. So this will be not that same molecule as earlier. So for this molecule only one rotation is possible. So that one will be a 360 degree rotation. So here only one operation like C1 is present. If C1 is present, like this is called E operation, or the point group will be E. For the next molecule, this one,
120. Sorry, 180.
so 180 degree rotation from, then we have to find out that what sigma plane are present in this molecule. So 180-degree rotation means this molecule have C2 axis. Then if you're cutting this molecule like from this side, like this two hydrogen, like when you compare will be like point group consideration, and we are compare like this hydrogen as a pair. So if you're cutting this pair, half of side pair will be our side and half of will be their side. And if you place a mirror plane between these two, so this will be mirror image of each other. So there will be one sigma plane is present, right? Then we have to find out this sigma is sigma v or sigma h. So if you contain this sigma at a principal axis, so that will be sigma v. If you not contain the principal axis, like if there will be possible a sigma h or not, so there will be no possibility of getting sigma h. So if you,
Sir, sir, please repeat the second one. How 180-degree rotation gives indistinguishable structure.
so if you consider like this molecule is like this. So if you rotate this molecule like 180-degree, then what will happen? So this two fluorine will be interchanged between this. Oh, sorry, not. So there will be no C2, is nothing is present. Sorry. So if you rotate the 180-degree, then what will happen? So 120-degree rotation will be this hydrogen replaced by this fluorine. So 180-degree rotation will be like this. Then where the hydrogen will be coming here, and here this two fluorine will be go there. So these are not same as a your parent molecule one. So there will be no C2 axis present. Sorry. So this on the case only there will be only sigma plane is present. So then this, if there will be no C2 axis, only sigma is present, then this point group we can tell as like S, CS. Then another one is the inversion center. So like inversion center is a point from where that all that position are equal distance, all opposite position are equal distance. So that point we are called an inversion point. So if any molecule that inversion point is present, then we are naming as point group as CI. So first example of this molecule one, the hydrogen fluoride. So what are symmetry rotation present on this molecule? So hydrogen fluoride, you can consider this is a pair, this also as a pair. Now if you rotate this molecule, so if you rotate these two pair from this side, any rotation like 1 degree, 2 degree, 3 degree, or any rotation, that will be give that same molecule. But if you rotate this molecule from this side to this side, so that will be not same. Now we have to find out, so this, so what will be the angle that C infinitive rotation, it will be give that same. Now we have to find out there will be any sigma plane present in this molecule, not. If you cut molecule like this side, like two pair will be cutting, and those are mirror image to each other, so this the sigma plane is present, and the sigma plane is that contain the principal axis, so this will be sigma v. So our point group name will be C infinitive v C, and there will be comes that what number of operation are present into the principal axis. For this case is the infinite number of that rotation can be possible, which can give that same molecules. So this will be point group will be C infinitive v. For the next one, so that D term only comes when there will be sigma H present in that molecule. Like here for the cases, so if you rotate like this molecule, the infinite rotation from this, so this will be acts as the same molecule. So if you rotate this molecule vertically, infinite rotation, this will be kept that same molecule. And if you cut this molecule like this side, that is that horizontal side, and it's the perpendicular to the principal axis, so if there will be any sigma H present in your molecule, then the D term will become. If there will be no sigma H and your principal axis is one principal axis, then C term will become. If there will be multiple principal axis present into a molecule, then in the point group that D will become. So here will be the multiple principal axis present, like infinite number of principal axis you can. And your principal axis, the C2 axis will be like D term will be coming where your principal axis, like if you call that C principal axis is perpendicular to that C2 axis, then D will come in the point group name. Similar like water molecules, what symmetry are present? Like if you rotate this molecule 180 degree, that is a C2 rotation is present, and there is sigma H present or not. So there will be no sigma H present into that molecule, so that will be D is not coming. And if there will be multiple C2 present or not, if there will be not multiple, only one C2 is present, then C will come. If there will be multiple C2 is present and your C2 is perpendicular to the principal axis, then this D term will be coming. So for these cases, this will be C2 and there will be sigma V is present. Like if you cut this molecule like this, so that point group of this molecule will be C2V. Now the next example one. So what the name of this molecule? Someone can tell.
1,2 dichloroethene.
1,2-dichloroethene. So for this molecule, what rotation can possible that will give that same molecule? Like this?
Sir, can I tell?
Yeah.
If we imagine the plane of the board or the plane of the screen, then if we imagine a axis, an axis passing from uh, front to back side,
Hmm.
then if we rotate at 180 degree, then we will get indistinguishable one.
So axis will be like this. So it will be passes through the molecule, and if you rotate like this, so this Cl will be coming here and this hydrogen will be goes there like that, so it will be indistinguishable one. But if you rotate this molecule like this 180 degrees, so Cl and H will be replaced each other, but that was not indistinguishable one. So only here it is C2 is present, there is not multiple C2 are present, and this C2 is present only, like if you consider like this one is the x y direction and that above and below the plane is that z direction, so only that z directions angle we give that C2 will be your that C2 rotation which give the indistinguishable molecule. Then we have to find out there will be any sigma plane present into this molecule or not, and how it will be. So if you cut this molecule like this direction, so there will be not indistinguishable because this hydrogen Cl are not same. So you can cut this molecule like that. Like you can't cut this if you consider like this this pair of this molecule. If you cutting in between this pair, like we cut chlorine half, hydrogen half, and lower down it chlorine half, hydrogen half, then there will be one sigma plane is present. But this sigma plane, if you if you consider like your notebook, and in between notebook if you placed in that table which are that like a sigma plane, and your above, like you place one pen above that notebook, that is your principal axis. So that principal axis is the perpendicular to that your sigma plane. Then what will come is sigma b or sigma h.
Sigma H.
So sigma h. So and here it's not possible that multiple C2 axis is present. So only one C2 axis. So we are not going that point group of D. So we are in that C, and there will be sigma H present. So that point group of this molecule will be C2H. Now the next molecule one, that the metal will link with that ethylene diamine. The 3-ethylene diamine is present in this molecule. And what rotation will give this molecule that indistinguishable? Hello. So if you consider like this molecule, and like similar, like if you consider like this bond, if you place a plane like this side, and if you rotate this one like 180-degree rotation, then what will happen? So this NH go here, and this NH which is up, it goes down like this. So it will be remain same, and this NH will be down, it will be going up. And here also one NH will be going down, one NH will be going up, but this side is same, so they are indistinguishable to each other. So there will be possible of C2 present from this side, also C2 from this side, also C2 from this side. And if you rotate, if you consider like this is a pair, and this is one term, and this will be your another one, and this will be another. And if your principal axis will be like this, and if you rotate this one at 120 degree, like around the z direction, so these all are replace each other. So what will happen? So there will be one C3 axis is present, which are going through this bond CO carbonyl cobalt. Sorry, going through this cobalt. So and then I am telling that and tell there like that. So there will be three C2 is present, and your one of C2 is perpendicular to that your C3 axis. So if it will be like that, your principal axis like C3 is your principal axis, which will be highest order, and which is the perpendicular to your C2, and if there will be multiple C2 are present, then your D will be coming. So point group name will be D3. Then we have to find out any sigma plane present in this molecule or not. Here it is, any sigma plane which is present. So there will be no sigma plane is present. So that point group of this molecule only will be D3. Next is the BF3 molecule. So what are the symmetry rotation present in this molecule?
C3
C3. And there will be C2 is present or not?
present, sir.
And C2 is perpendicular to the principal axis or not? How the C2 will be like this? So your principal axis C3 will be similar like this, like passing through this boron atom, and your C2 will be like this, which is that like through this bond. So like this will be the perpendicular direction, like this will be throughout this bond, and your principal will be like this, like around above. So this will be perpendicular to the principal axis. So if here there will be multiple C2, and from this side also one C2 present, this side also one C2 is present. If there will be C3 and C2 is present, and there will be more than one C2 is present, so there will be three C2 is present. And if this C3 is perpendicular to the your principal axis, then the D will be coming. Now we have to find out, so this will be D3. Then we have to find out that will be sigma plane is present or not, and how this sigma plane it was. So now the sigma plane will be like this. So if you cut this molecule, so there will be sigma V also present, like you were cutting from this side, also sigma is present. If there will be sigma is present, then this will be D3H. If there will be any sigma H present in your molecule and your configuration is D, then that will be D3H. And if there will be no sigma H present in your molecule, then that will be D2. If there will be no sigma H, then this will be D3D. So here the point group will be D3H because here that sigma H present in this molecule. Now for this alene molecule. So for this alene molecule, if you rotate like this from the Z direction, that 180 degree, this will give that indistinguishable molecule 1. And also this molecule we can consider like a cube box like that. And in that cube box, your hydrogen are alternatively placed to each other. Like this, it will be your carbon. Then one hydrogen will be like this, another hydrogen will be like this, and there will be another hydrogen will be like this, and this like that. So and also there will be another C2 is present like inclined 45 degree if we incline it, and if you rotate like this one, so there also C2 is present. So from this side also similar like this, there will be another C2 is present. Like one is from this that throughout this carbon atom, and another like this side one, and another is this side one. So there will be multiple C2 is present. If there will be multiple C2 is present and your C2 one C2 is perpendicular to that another C2, like this one is the perpendicular to like this one, so there will be D will come. Now we have to find out there will be sigma V or sigma H present or not. So this will be a D2 comparison. And there will be one sigma H plane will be present like this. If you cut this molecule throughout this hydrogen atom like this, so if there will be 3 C2 H present, so there will be 3 sigma V also present. And if there will be any sigma H present, like if you cutting like this side, so here also one sigma H also present. Sigma H present or not? So there will be no sigma H for this molecule, so that point group of this molecule will be D2D. So this the summary one like that. So if there will be only one C1 is present, so we can tell like this one as only E. If there will be only sigma plane, one sigma plane is present, the point group is CS. If there will be inversion center, the point group will be CI. Then number of symmetry. Then we have to find out that, find the highest order of Cn, like C3, C4, C6 part. And then we have to find out that your C4 or C3 axis is perpendicular to your principal axis or not. If they are perpendicular to the principal axis, and there will be multiple principal axes, multiple C2 is present into a molecule, then D will coming. If they are not perpendicular to the C2 axis, then C or S will be coming. So if there will be sigma H present, then that will be DNH. If there will be no sigma H present, only sigma plane is present, then there will be D and D. And if there will be no sigma H present, that will be Dn. And for which have not perpendicular to the C2 axis, then that will be, if there will be sigma is present, that will be CNH. If there will be sigma V present, that will be CNV. And if there any improper, there will be no sigma H, no sigma V. So maybe there will be possible to S2N rotation. If yes, that will be S2N. If no, that will be CN. Then for this molecule, what point group of this molecule? Hello.
Yes, sir.
Yeah. So what operation are present in this molecule? Like this, if one point is like will be like this, it's go throughout the bond. And if this are rotate, if this is rotate 60 degree, like this methyl will coming here. If you rotate 60 degrees, so this methyl will coming here. If you rotate 120 degree, then what will happen? So this methyl will be coming here, and this methyl will be coming here. So these are indistinguishable or not?
indistinguishable হবে।
Okay. So there will be C3 is present. And if you're cutting this molecule like this axis, and if you rotate like this 180 degree, then this will be C2 is present. There also C2 is present. So if there will be C3, which is the perpendicular to your C2 axis, and you have, so if you have C3 which is perpendicular to principal axis, so D will come. Then we have to find out there will be sigma plane are present or not. And if the sigma plane is present, we have to find out that will be sigma A is present or not. If you cut this molecule like this direction wise, like all methyl is cutting, and your principal axis is above the plane like this, So it is perpendicular to your sigma axis. So there will be sigma is present. So if sigma is present and there will be multiple C2 is present and your principal axis is perpendicular to the C2 axis, so this will be D3, and if there will be sigma is present, so this point group will be D3H. If there will be no sigma H present, then there will be D3D. If there will be any sigma plane is present but no sigma H. Now this one is earlier all I told same like that. Like for this molecule, so this molecule will be like this. Like if you consider like fluoro or methyl anything. So what point group are present in this molecule, or maybe another one we can consider like this alternative position. There will be fluoro. This two are down, fluoro. Oh, sorry, this is down. For the last one, maybe this one, that example set told in the class. But this one, so what symmetry operation are present in this molecule? So if you like your notebook which is hanging to each other, and from that which is hanging in between this there will be one rope, and if you rotate this rope like 180-degree, then what will happen? So your this fluorine is coming here and this fluorine is going there, and the lower one, this fluorine is coming here, this fluorine is coming there. So this one is possible, that indistinguishable one. So this one is indistinguishable, so there will be one C2 is present. There will possible for another C2 in this molecule.
Please repeat this.
Like if you consider like if you consider like this bond will be like this, and if you rotate this one like 180-degree like this direction, so what will happen? This one, like you put it like this, so there will be one fluorine above and this one is above, and that too this one is down to fluorine. And if you hanging this one like from this point, and if you rotate this one, it's 180-degree. So these are indistinguishable or not? Because if you rotate this one 180-degree, then what will happen? Then this fluorine is coming here or not?
Okay, sir. Yes, sir. Indistinguishable.
So this one is also coming here, and that lower fluorine one also coming here, and this one is coming there. But there will be another C2 is present or not? Any C2? Maybe not. So there will be only one C2 is present in this molecule. Then we have to find out there will be sigma is present or not and how it was. So your one sigma will be like maybe like this. It will throw out that principal axis. Like from above you cut your two fluorine half up, and in between it will be cut, and this will be this fluorine and this fluorine are opposite to each other. So there will be one sigma H plane is present which contain the principal axis, that is your sigma B. There will be sigma H present or not. Sigma H like this. So if your one plane will be like that, if you're cutting like this throughout the bond, if you're cutting like this, so here that lower there will be no fluorine, so there will be no sigma H present in this molecule. So only one sigma B is present and C2 is present. Then what should be the point group of this molecule?
Sir,
What?
sir, here 2 sigma be present or not? Like, I mean, 2 sigma be.
2 sigma B how? Like from this side also, yes. 2
Yes,
sigma
yes.
B present. From this side also if you cut like that above one, like mirror image of each other, and the below one is cutting to each other. Yes, 2 sigma B is present. Then what should be the point group of this molecule? Here only one C2 axis is present. So the D will coming if there will be multiple C2. So there will be no multiple C2, so only one C2, the C will come. Then we have to find out sigma B or sigma is present, so only sigma B is present. So the point group of this molecule will be C2B. Okay. Now that we have to draw the Newman and Schwarz projection. So when someone tell like in between this bond and this bond, so these two bond which are in the Newman projection, which are the main, the connecting point, and another will be that other point. So here there will be hydrogen to hydrogen, and there will be methyl, this one also methyl, and there will be two hydrogen like this. So it's like a which projection? It's like a Newman Schwarz projection.
The screen is not visible, sir. Visible.
Not visible.
So now visible. Now visible.
Okay. So there will be two projection. Like if you draw someone, there will be one is that Schwarz projection. It will be like this, and if you go this Schwarz to Newman projection, so it will be represent like this way. So this confirmation is called eclipse confirmations. If another confirmation will be like this, which is called staggered confirmation. So if someone can draw from these 2 points, if you want to draw like this Newman projection, then what will be your that, so your one methyl group is above, like from this side if you're starting from this side, so your one methyl is up and two hydrogen is down, like this, and that lower one methyl is down and two hydrogen is up. And if you project this one as Newman projections, so directly this will be like this. So your one methyl will be here, and this will be your two hydrogen here. This will be your hydrogen, and then below one will be your methyl. And if you convert this staggered conformation to eclipsed conformation, then your two methyl will be at same position. Then someone asks that which conformation is more stable. So if there will be two methyl it's coming close to each other, then that due to steric crowding, this will be less favorable conformation at as like staggered one, where the two methyl is far apart, which are the bulkier group in this molecule. So this staggered conformation will be mm, much more stable as compared to this eclipsed conformation. And if someone like if you tell like in between this point and this point, if you draw like this, so this is your main connecting point. If someone like tell like this is your connecting point and this will be your whole one, so then this will be your ethyl group, whole ethyl group, and this one will be two hydrogen and there will be three hydrogen in this. So like that. So one place will be ethyl and the below one will be all the hydrogen and another one is the two hydrogen. It's like that we have to draw. So you have to point out that which your connecting point and in the connecting point what substituent are connected to each other, like that. Then we have to draw that it's Newman and Schwarz projection if someone tell to draw. Up to this part all of you understand? Hello.
Yes, sir.
Okay, so today's
Yes, sir.
classes we are up to this part we are doing. So new that one new today. I don't know. Can you tell from where are you from and which college, what you are doing?
Sir, I am new. My name is Shongita Kundu, and I am a student of Jadavpur University, Chemistry, UG1,
Okay,
last year.
so you are batchmate of this.
Yes, yes.
Okay, so thanks for joining today's class. So next class onwards we also solve some problem that regarding your assignment, so that will be help to solve your assignment better.
So,
Okay,
what type of question can be asked? Subjective or objective in examination?
maybe I don't know, but in your assignment there will be like first two classes there will be maybe MCQ type question, but when you are
Sir, in second assignment, there is a subjective assignment. In
yeah,
second week, there is a subjective assignment.
also after that maybe that will be subject to assignment because you have to mm, there will be some reaction also like that, elimination, SN1 SN2 reaction,
So
something like that.
in examination, wow, the objective.
Examination maybe that both some multiple choice question and subjective question. Maybe because I am not mane what tell I am not associate with that person that which are doing when settle the question for the exam. I am only here to just what type of question they may be to understand the subject only.
Okay, sir. Thank you, sir.
Hmm. I can share because this professor from my institute. So if I know that what type of question come in the exam, then I will also tell you.
Yes, sir. Please ask the professor about questions.
Okay. So thank you all of you for the joining.
Thank you, sir.